There we go. All right, so as much as I love that clock, I'm going to get rid of it for now. And then we'll put it back when we have our big world out there until we can get our other clock to come back. Anyway, we are on to lesson 13. We were at lesson 11 on Friday where we started going back over some addition. And we decided to jump over 12 and we're landing on 13. 13 says I can use what?
Place value.
Place value understanding, okay? Knowing what's happening on that place value chart is really helpful in understanding what happens during addition, during subtraction, even multiplication and division. We'll see the place value chart some. But I can use place value understanding to decompose. Okay, decompose. That word is going to mean different things in science versus math, okay? But what are we talking about when we decompose something? What does that sound like we might be saying or talking about? And if a guess is fine here. Yeah.
Subtract.
Well, I mean, you can see that we're going to be subtracting, but decompose and subtraction don't mean the same thing. Okay, yeah. It really, we use it probably the most with our place value chart. So is there something on our place value chart we would do that shows decomposing? Will?
Like to write down a bigger number and
Yes.
a smaller
Breaking down, kind of, when we decompose to smaller units, we're borrowing from a bigger unit and we're bringing it into the smaller unit and opening up that bundle. Imagine opening that bundle of dots. If I had to borrow a 10 and bring it to the ones place so I'd have enough to subtract, I'm decomposing that 10. I'm taking it from the tens and I'm opening it up and letting it be ones. So some of them can be taken away. Okay. Okay. I can use place value understanding to decompose to smaller units once using the standard subtraction algorithm. A lot of large words here. And apply the algorithm to solve word problems using tape diagrams. It's a mouthful, isn't it? Okay. Standard subtraction algorithm. What do you think that is? On Friday, we used the addition, the standard algorithm for addition. What were we doing? We were just adding, like regular adding. So this might sound scary and very fancy. We're just subtracting, okay? We're going to use some place value understanding to let it help us understand what's happening in subtraction. We're also going to try a little bit to start using tape diagrams in a word problem, and you'll see how that works. That might sound scary too. It's not. Okay. All right, just for some warm-ups here, if you grab your marker on your board, we're going to do a little adding. We'll get to subtraction eventually. What do you think you need to write on your board to help you do this problem? Are you going to write it exactly like this? I guess that's what I'm asking, Charlotte. You need to stack them, don't you? I just call that stacking your numbers. I guess you could call it putting them vertically instead of horizontally. But if you would go ahead and put those two numbers together on your board. Okay? Right here. Let's get our brain going in this direction. And this is not subtraction, this is addition. Watch your signs. We're talking about subtraction today, but this is just those warm-up problems. So this is addition. All right, so Charlotte's already said this. But when you wrote it on the board, I didn't see anybody leave it just like this. We stacked it up. When you put two numbers like that together to add or subtract, what's one important thing to remember about the way you write them?
Yeah. Put the biggest number on top.
Okay. Things will be a little smoother, a little easier if you do put the largest number on top, but also what?
You're supposed to keep your lines in one line.
Okay.
The ones in one line.
Keep the ones above the ones, the tens above the tens, the hundreds above the hundreds. And in what we're doing today, it's almost helpful to imagine. No, I'm just going to draw lines because sometimes those dotted lines make it look even messier. But if we remember, this is the ones, and this is the tens, and the hundreds. Okay. Okay. So 3 and 6 is what, everybody? Come on, I need everybody with me. 3 and 6 is 9. All right, 7 and 1 is 8. 4 and 3?
7.
Okay, did we have to do anything difficult there, like carrying? No. Okay, that was pretty straightforward. Okay, let's move to this one then. This one. Okay? Give that one a try. 2 ways to do it. Stack all 3 numbers up together, or add 2 and then add the other one to that answer. There's a lot of 6s and 2s and 9s in that number, so be careful how you write your numbers. Where's your eraser bag? Is the whole bag at home? I need you to find it. Okay. Which of these 3 numbers is the largest?
No.
Do you know? We have 2 of these for a good reason. All right, which of these is the largest? Mason, go ahead.
962 and 629.
Okay, there's our largest. What's our second largest number, Miranda?
629.
Okay. And that would leave 296 as our smallest. All right, with something like this, if you're going to do all 3, very important to keep your numbers lined up. All right, everybody, the 2 plus the 9 plus the 6. 2 and 9 make 11, plus 6 more make 17. We're going to put that 7. 17 dots is too many to keep in the ones place, so we're going to take that 10 and move it over to the tens place. So now we've got 1 and 6 and 2 and 9. So 7, 8, 9. 9 and 9 is 18. Okay, I put down the ones place of the 18 and I carry the 10. That makes 10 plus 6 more is 16, 17, 18. 1,887. Who got that? Several of you did. Okay. Good. And just, you know what? yesterday when we did a little subtraction practice, told me we all need a whole lot of subtraction practice. Okay? But one of the biggest things about adding and subtracting these larger numbers is not that we don't know how to do it, it's just these little itty bitty mistakes that happen along the way. Okay? What we call them careless mistakes just because we know what to do, we just made a small error. Okay? So we've just got to be careful. All right, we're going to move on to this one. Okay, now look at your sign. It has changed. Okay, let's go ahead and put this one for a warm-up, and then we're going to jump into our real lesson today. This is actually a very quick problem, isn't it?
Yeah.
Should be. Okay. Yesterday, in second period, I had somebody that had this situation of a 0 on the top and a 0 on the bottom. And they got stuck. And they asked for help, which is good. I want you to ask for help. But they got stuck because sometimes we forget how 0 and 0 act with each other. Okay? What is 9 take away 5? Let's do that first. Okay. What is 0 take away 0?
0.
0. And we forget that as simple as that is, we forget that equals 0 because they were trying to borrow so they could subtract there. So twice we've got 0 minus 0 and then again the 9 minus the 4. So that was a pretty quick one. Didn't have to do any borrowing. Okay. All right. I guess I told a little bit of a story. Let's see. Are we going to do that today? Yeah, we are. I'm going to switch the order here. Okay. These are our roundups of our review slides. Okay. And they threw one in about rounding. And I thought, it has been a little while since we've done that. So let's do this right now. Then we'll jump back into our addition subtraction thing. Here we have a very large number in the millions. Okay, I want you to round it to the nearest 100,000. Okay, now you choose the way that you do that, but we don't want to forget this skill. We worked too hard to get it.
Does it have to be on a number line? Does it have to be on a number line?
So you choose the way you do it. But if you're getting stuck doing the number line because that's what you started with, try it the other way and see if you don't get stuck. Okay, about 30 more seconds. Is this one of those tricky ones?
Yeah.
No. Yes.
Yeah.
Very different
Yeah.
reaction. Okay. What's funny is we're going back and forth between skills. We've got addition, we've got some subtraction, we've got some rounding. And different ones of you in the room are better at different, like, the rounding people are like, yeah. And the subtraction people are like, yes. And the people who hate subtraction are like, oh, you know. And so I can see it in your faces. When something comes up that it's your thing, you're like, yes. So, all right. Find that 100,000th place all the way right here. Look right here. Okay. That 8 is going to tell that 9 to do something. Okay. That 8 is going to tell that 9 to do what? Go up. When a 9 goes up, it becomes a 10. 10 is not going to fit right there, is it? It's too big.
It's not going to fit.
So it's almost like adding, you're going to push some out into the next space. So that 9 is not going to become a 0. It is going to become a 10. You cannot forget to do that. You can't just turn it into a 0. That means you're taking away 9, not adding 1. Okay? So that means this is also going to become a 10. And what happens to all the rest of these digits?
0.
Zeros, and that's 5 this time. 1, 2, 3, 4, and 5. So 10 million is what that rounds to. Okay. It sounds strange to round to a number that you say million with when you're rounding to the 100,000th place, but that's it. Okay. All right. Let's jump back here. Let's jump back here. There we go.
Can we erase?
Yes, you can. All right. We're just getting warmed up. There's just a little more warm up this morning. Some days there's not much at all, and some days there's a lot. Okay. Now, we have not done an application problem in a while, and I do want to stop and do these every so often. There's something about this problem that tends to get us. So I'm going to let you read it. I'll read it. But I'm going to let you work it completely on your own and just see what you come up with, and then we're going to talk about it. Jennifer texted, 5,849 times in January. In February, she texted 1,263 more times than in January. What was the total number of texts that Jennifer sent in the 2 months combined, January and February? Explain how to know if the answer is reasonable. Now, right now, we're not going to worry so much about this last sentence, but we are going to find that question mark. Okay, guys, hold on. What was the total number of texts that Jennifer sent in the 2 months combined? That is your main question to answer. So take a minute and do what you think needs to be done to find that answer. And then we'll go over it. Okay. So I'm looking. A lot of our boards look alike. There's a few that look different. Okay. So let me show you something that happens a lot with it. We get this type of question all the time in 4th grade, and it tricks us and it gets us. Okay. There are 2 months that we're trying to figure out how, if we put all of her text together, we want to know how much she texted in those 2 months. The month of January and the month of February. Right? Because we know. The question says, what was the total number of texts that Jennifer sent in the 2 months combined? So if we have the right January number and the right February number, all we do is put them together. So who knows the January number? What is it? Find it for us. Find it. Everybody has eyes. I know you all can do this. Martin, what is it?
5,849.
5,849. It says Jennifer texted that many times in January. It says that. Very plain. Yes, that is correct. For January. How many texts did she send in February? How many?
7,112.
Okay. Anybody else get 7,112? I don't see that number up there. Okay. Did they get that just for February? Just for February. Okay. Gone are the days, guys, where we can just grab the numbers we see and add them together, or subtract them. Okay, you've got to read it carefully. In February, she texted this many more times than in January. She did not text 1,263 times in February. She texted that many more times. So to find my February number, I've got to add my January number plus that. Okay? So January is that, but February is both of those numbers together. So first I've got to add these two together. And what is it that you got?
7,112.
7,112? Is that what I got for? We'll go with that. 112? Okay. So I've got to add my January number and my February number, correct?
Yeah.
To get the final, how many texts she had all together in those 2 months. So a very quick adding. Sorry, this is a little hard to read. Okay, 11, go up. Okay, carry that, so that would be 6, that would be 9, that would be, so 12,961. 12,961, what? No, I read the number. What goes after the number? Text. That's what I was looking for, that word. And we'll squish it in the corner. Okay. So, as we go through this year, like I said, we'll come to one of these where if we don't read it closely, we're going to get tricked by it. Okay? All right, we're going to move on from there. Go ahead and clear off your board. Okay. So, what is this yellow thing?
The place value chart.
It is the place value chart. Okay. They just don't like to label it for some reason. Okay. Here is our place value chart. You know what? You asked me earlier, do we need our place value chart? And I didn't think I was going to have us do that. I think I am, okay? Because these numbers get so large, it would save you drawing that place value chart a few times. So if you would very quickly grab that out of your binder. Sorry about that. I just think it will save us space and a little time, okay? Okie doke. We have two numbers that we're going to put on the place value chart. So, really and truly, we also want a place for our answers. So if you would take your place value chart and draw a line here and a line here, you're cutting it into 3 pieces. Okay. Let's see. I'm just going to extend mine a little bit. Okay. So we're going to put 4,259 on our place value chart. We're going to do it with dots instead of digits. So 4,000s. I'm actually going to do this. In your top spot, you're going to put 4 dots in the thousands place. We're just going to, no, not digits, dots. Okay, because we can see what's happening better if we do that. In our hundreds place, we've got 2. We're putting this number right here on the place value chart. How many 10s then are there?
5.
5. How many 1s?
9.
9. Okay. 4,000s, 200s, 5 10s, and 9 1s. Okay, so under that, we're going to put the other number. 2,000s, 100, 7 10s, and 1 1. Okay. All right, there's another way to do this on the place value chart. We're going to try it this way first. We might like the other way better. We'll probably try it in a minute. All right, so let's slowly go through this together. With my 1s, I've got 9 up here and 1 to take away. Can I do that easily?
No.
Sure I can. So how many will we be left with?
8.
How many?
8.
8. 9 minus 1 is 8. Okay, we had 9. We took that away. We've got 8. Okay, let's show that on our board. All right, what about the next one? We've got 5 10s, and we've got 7 to take away. Are we going to be able to easily do that?
No.
No. So what do we do? I need you to stop and just watch for a second, okay? To show this, we would go next door and grab one of those and draw an arrow to show it's coming back. But when it comes back, it doesn't just stay one dot. It decomposes. It's almost like that dot is a zipper bag, and it's almost like somebody opens it up and those 10 tins come out, okay? So now when we pull it over here, it's going to become, there's 10 of them. You see that? When this came over, we opened it up. We decomposed that 100 into all these tens. Because 100 is 10 tens. Okay, so make sure you've done that on your board. Grab one of those hundreds, just kind of like lassoing it, circle it, and draw an arrow back to the tens. And add those 10 dots. It's a tight squeeze a little bit. Okay. Okay. Now we have 10 tens that have come over. We had 5 before, so now we have 15 tens. We can now easily subtract 7 tens. When we had 15 of them and we subtract 7 of them, what are we going to have left? 8. So put our 8 tens down here. Okay. Remember, this place value chart is what's happening behind the scenes when we do a problem like this. Okay. Are we going to draw that chart every single time? No. But I want you to get that visual in your head of what's happening. All right, so we are left with, be careful here, we are left with just 100 here and 100 here. Can we take 1 away from 1?
Yeah.
Sure we can. We'll be left with how many?
0.
0, so just leave it blank. If it were digits, we'd write a 0, but since it's dots, we'll just leave it blank. Thousands, we've got 4 and we've got 2. So 4 take away 2 is 2, of course. There we go. Now we're just going to change these dots down here, or discs, to digits. This becomes a 2, a 0, an 8, and an 8. Okay? Now, let's go ahead and do the problem. Slide your place value chart just to the corner. Don't erase it, but put this in front of you. But put them side by side so you can see them. Okay, mine are side by side already. Okay, we're doing the exact same problem. 9 take away 1, which is what we did here, and we got 8. I guess I should give you a second to write the problem, huh? Okay, go ahead and write that problem. I'm just in supersonic speed this morning. We couldn't take the 7 away from the 5, so we went and borrowed right here. This is what we did right here. This became a 1. There was only 1 left, and this became a 15. 15 take away 7 is 8. 1 take away 1 is 0. 4 take away 2 is 2. Same answer. Okay. All right, just erase the problem board, the whiteboard. Leave the place value chart for right now. Okay, lay your marker down. Actually, just put the top on it and lay it down. how many of you, if you had to choose between addition or subtraction, you would choose addition? Raise your hand if you like addition better than subtraction. Gotcha. Okay. Message received, loud and clear. All right. Raise your hand if you like subtraction better than addition. You like both. That's fine. You know what? I could kind of tell that yesterday. Guys, subtraction is important though, and we've got to get better at it. Okay. And I think the better you get at it, the more you will like it, or at least you won't hate it as much. Okay. It is not okay to reverse the order of your numbers in your mind. This is what I mean. It's not okay to go, oh, 2 take away 0 is 2. 2 take away 1 is 1. 4 take away 5. I can't do that. Let's just do 5 take away 4. You can't do that. No, but you seriously can't do that. Okay? Another thing that we've got to remember is when we borrow from next door, it's like going, we said this yesterday, it's like going next door and maybe borrowing an egg to help cook. Okay? When I borrow something from someone, I'm trying to see on your desk. You've got more than one. Okay. Can I borrow a marker? Would you put one in my hand? Okay, now everybody look before he actually hands it to me. How many does he have?
1.
No, how many does he have right now?
2.
He has 2. I'm about to borrow 1, and when I take that away, what does he have left? 1. He has less now, because I took part of it away to use with something else. Yesterday, I noticed some of us were borrowing, and we were making that place that we borrowed from have more. Okay? So we've got to be very careful. If I get to let me put that back. If I get to here, and I have to borrow from the 3, I'm going to cross it out, and it's going to become a smaller number because I'm taking some away from it. It's going to become a 2. This gets larger. That's a 14, even though it's an odd-looking 14. This gets larger because I just added a lot to it. 14 take away 5 would be 9 then. And then I can keep going. Okay? All right. So, go ahead and write this problem on your board, on your whiteboard. Before you start to work it out, I want you to stop. Just write the problem and then stop. Okay, don't let this take too long. Okay, you've got the problem, right? You've got the line under it, you've got the subtraction symbol, make sure you have all the parts. Okay. This says to draw a tape diagram. Raise your hand if you've ever seen a tape diagram before. Just a few. That's what I thought. A tape diagram looks like a rectangle, a long, skinny rectangle. And it usually gets cut into pieces somehow. The thing is, with a tape diagram, you can make it work with just about any problem that you do. Guys, this is our total, 23,422, and this is one of the pieces. We're going to take this piece away and see what piece we've got left. So our whole tape diagram, you're not drawing anything right now. This whole thing is 23,422. From this side all the way to this side. Do you see that? Please put the top on your marker and lay it down. Okay. This whole thing is 23,422. One of the parts is 11,510. Right here, right? When I take that away, I'm trying to see what I have left. I don't know this one. I'll put a question mark right there. I don't know what that piece is. Okay. So when I add this piece, which is here, and this piece, I will get this number. When I subtract this number from this, I'll find the missing piece. That's how a tape diagram works. Okay. We're not going to use them a whole lot today. I just wanted you to start seeing them. Okay. All right, go ahead and work the problem, and let's see what actually does go in that box. Go ahead and work this problem. Make sure your numbers are lined up. Right now, we're going to work the problem. Miranda, what'd you get? Or just walk me through here, okay? 2.
1.
1.
I took 1 from 3 and put it over to the phone.
Okay. So that becomes a 14.
9.
That's a 9.
1.
2 take away 1 is 1, and 2 take away 1 is 1. So 11,912, and that would be what goes right here. So this tape diagram shows us, oh, well, these two numbers added together make this one. These two numbers added together make this one. This one subtract this one would make this one. Or this one subtract this one would equal this one. Okay. All right, go ahead and clear that off. All right, this is our last practice problem before we talk about our problem set. But this time it's got sentences wrapped around it. Are we going to run for the hills? Or are we going to, no, we're not going to let that bother us. All right, Bailey, can you read that nice and loud?
The paper mill
Produced
73,658 boxes of paper. 8,052 boxes have been sold. How many boxes remain?
Okay. A paper mill is like a big factory that makes paper, if you didn't know that. Okay. So to produce something is like to make it. So it's like a factory making something. So the paper mill produced this many boxes of paper. This many boxes have been sold. How many boxes remain? Okay. Can you, for just a second, try to draw a tape diagram that would go with this problem? Let's just practice that for just a second. What would a tape diagram look like? Now just give it a try. We're new at this, so no big deal. Remember, it's a long, skinny rectangle. Think about what the whole thing is. And think about, do I have any of the pieces? What is the whole thing for? How many boxes of paper did the paper mill produce? I'm going to do it underneath just so there's more room. How many boxes of paper is this whole thing? Gage, how many would you say is? How many boxes did the paper mill start off with?
73,650.
There you go. So this whole thing is 73,658. Okay. What is one of the pieces that we do know? Because, like, how many did they sell? We want to know how many are left. So, Ishmael, what do you think?
8,052.
Yeah. So that's a little bit smaller if we wanted to really draw it correct. Oh, 11,000. I still have my mind on that other problem we just did. Okay, 8,052. Okay, so the paper mill had 73,658 boxes. It sold this many, a piece of that. What do we have left? That's how the tape diagram would work, or one of the ways it would work for this problem. Now, what type of subtraction problem, not what type, but what would your subtraction problem look like to go with this? So put that on your board as well. You want to be able to find the other piece of that tape diagram. So what would that subtraction problem look like? This is what I'm seeing on most of your boards, that you're starting off with 73,658, and that is correct. You would start with that for our subtraction problem. You would subtract the piece that we do have to find what we don't have. We would subtract 8,052, and a lot of you are in the process of writing that right there. Okay? So once you've got that written, go ahead and subtract. Let's see what is missing. You guys are working hard right now on something you don't even like. You just told me a minute ago you'd rather be doing an addition. So even when it's something that's not our favorite, you're jumping in there and working hard, so keep it up. Good job. Okay, keep going. Alright, let's have a 4th grade answer. This is a word problem. So it's not just going to have a number for your answer, it's also going to have something else with it.
Oh.
Yep. Okay. Trying to give everybody just a couple more seconds to finish that subtraction. Don't let your arm fall off. They do come in handy every now and then. All right, Mr. Brandon, can you walk me through this? Let's just go all the way through it.
I was going to tell you the answer.
Yeah, I know. So
Our answer is 65,606.
you got 65,606? Is that what you said?
Yeah.
Did anybody else get that answer? Several? Okay. I'm going to come over here and just walk through because if you did not get that, I want you to see where you might have made a small error. 8 take away 2 is 6. 5 take away 5 is 0. 6 take away 0 is 0. 3 take away 8. It's not 5. You can't do that. You've got to go next door and borrow, which makes that number 1 less. That bundle comes over here, that extra bit of 10, and makes that a 13. 13 take away 8 is?
5.
Okay. And then the 6, it comes on down, doesn't it? It's like subtracting a 0 there. Okay. What do you want to add on, Will?
I can add on to Brandon because it's 606 boxes.
Okay. Boom.
He nailed it!
Okay, it's been a while, so, let's try that one more time. Boom!
He nailed it!
And boom!
He nailed it!
Okay, so together, you could have said boxes of paper. You could have, you ready for this? You could have, the paper mill now has 65,606 boxes remaining. You could have written some fancy sentence like that. But if you just had the word boxes, that would be perfectly fine. Yes.
I wrote the United States 5 still, but I still got the right answer.
You did what?
I still got the right answer.
But what did you do?
I did the United 8, and I still got the right answer.
Be careful, that's not always going to work. Okie doke. So our problem set is going to make you very happy. Look at there.
Oh, wow.
Now, I want to show one of these to you before we get going, okay? Because these are necessary. Go ahead and, I tell you what, we just got a lot of distraction in front of us. If you would clear off your board,
Can we clear this?
clear off your place value chart, put it all away. You can go ahead and put things away and get out your workbook. Just leave the workbook closed. We're going to talk about it. We'll take our restroom break in a second. We will come back and get going with it.
Yeah.
Okay.
We're all excited.
I can tell. I can tell. Put it all away. Even your place value chart into your binder. Go ahead and lock that back in. Don't be last. Don't be last.
Oh,
Gage is already taking a nap. He's been.
I thought I was in my bed.
He had to too.
Thank you, Sarah. That's the closest thing.
It's nice. Okay. At least part of it's nice. You can do it a little bit at a time. You might can work on it during this fire. Take it with you when you go with Miss Jenny today. All right. Look at this problem. As much as you might not like subtraction, sometimes what people hate worse is when they see a lot of zeros with subtraction. All right, close your book for now and just put your eyes up here. Close your book for now and just put your eyes up here so you can hear this. If you start to subtract and there's nothing but zeros on the top for a while, you got to do something about that, don't you? Okay. Now the first one, 0 take away 0. Can we do that?
Yes.
Sure we can.
Yep. Yep.
Sometimes people forget that and they'll start borrowing for that first 0. Don't do that. It might mess you up later. You get to the next 0. Can I subtract 7 from 0? No. If I have nothing, I can't take 7 away from nothing. So I've got to go next door, change that to a 4, and this becomes a 10. 10 take away 7 is 3. 4 take away 4 is 0. 6 take away nothing is 6. Okay? Just wanted to remind you about those zeros. Excuse me. In another few days, we will have to borrow with zeros several times, and so we want to get good with it when it's there just a few times. Go ahead and slip your mask on, and let's get lined up.
Miss Elizabeth's class is down there.
Well, maybe in just a minute. By the time we get down there, they'll be mostly finished.